Hello and welcome to another video for the Hoylake Computer Club. This is Tom at the club. So I figured that we'd kind of carry on with this Python sort of stuff we was doing, and I thought I'd try a different way or an additional way of kind of putting across. So I had a look at CodeSignal. This is a thing where we can kind of solve challenges in lots of different programming languages. So I figured we'd do it in Python 3. So initially I was thinking do one a day, but there's a couple of really, fairly easy ones in the first bit. It does get harder over time, so hopefully we'll get to a point where we do like one a day, but I think we'll probably end up doing a few or a couple or a few in this one. I've tried them out and gone a bit down just ahead, just to see how hard they end up being. So for this, I think we're going to try and do 3 today, and then we'll kind of move on doing like 1 at a time or something like that, or 2 at a time, depending upon how much time they take up. So we've got the add, century from year, and check palindrome. So I figured I'd just do them in series, in the order which they come. So add is here. Now this is more just to get you used to the actual construct of CodeSignal itself. So in CodeSignal you've got a description, so it tells you what they're expecting of you. So write a function that returns the sum of 2 numbers. Gives you an example. So if parameter 1 is 1 and parameter 2 is 2, the output should then be 3. So this is a very, very simplistic one, but it's kind of more of a hello world to using CodeSignal. It tells you some expectations on input and output. So basically the execution time limit of 4 seconds, so it expects you to be able to run this in 4 seconds or less. So if it takes more than 4 seconds to run, it probably needs improving. I would not expect it to take 4 seconds to add 2 numbers together on a Python application unless you really wrote it really badly. It's quite hard to write badly, to be honest. So then it says the memory limit is 1 gigabyte, so it's saying, okay, well, don't expect it to go over a gig of memory usage during this calculation. Hopefully it wouldn't, since it's just going to be 2 numbers. The input's going to be integers, so you're going to have parameter 1, which is an integer, and you're going to have parameter 2, which is an integer, and it says it's guaranteed constants of -1, so it's going to be greater than -1, but greater than -1000, but less than 1000. So it's only going to be a fairly small number as well. Same with parameter 2, literally the same sort of thing. And the output's going to be the sum of the 2 inputs. It gives you a general look at syntax tips. It says, here's how we're defining a function. This is the function name, here's an input, and this is what we're expecting it to do. And then it can return something. So this is just an example of Python syntax. At the moment we have a defined solution with parameter 1 and parameter 2. It's expecting us to return the sum of the 2 of them. So when we're summing things, we know that we can just use the plus sign. So we can use the plus sign to sum things together. So what we could do is we could just return param1 plus param2. And that's it. That's all there is to it. So we're adding these 2 parameters together and then returning them. Let's run the tests and see how it goes. Again, we've got this run test button over here. This allows us to test it against some pre-made tests that they have. There's so many that we can see, so we can kind of look at what it's going to expect us to get as input and results. But then there's some hidden ones, which usually are edge cases for certain things and things. So you only ever get to see sort of like probably about half of the tests. So you don't always see exactly what the tests are. So you can't just only write to test. So you need to kind of think in and out of the box when you're working with this. But let's submit it, and that will go off and check against all the hidden tests and everything. And as you can see, it's correct. That's great. So that's that one done. Let's move on to the second one. So the second one's a little bit more complex. It says, given a year, return the century it is in. The first century spans from the year 1 up to and including year 100. The second from the year 101 up to and including the year 200, etc. So basically you're just kind of adding how many hundreds there are in the number, kind of. because it's got to be inclusive. So here's an example for year 19, is that 1905 or 1995? Either way, that would have been the 20th, because it's within century 1 plus 19, and 1700 will be specifically the up to the 00, so it'll give us a 17, not an 18. If that was 1701, that would have been the 18th century. So we're just bearing in mind the actual size. So what we could do, there's a couple of things we can do here by my way of understanding. We could either add 99 to the number and then divide it by 100, which theoretically would give us the century. Or we could ceiling the number, so we divide it, and then if we've got something point something, we add 1 to it. So there's kind of two ways of approaching this. I'm going to go with the first one I spoke about first. So let's take a look. So what we can do here is you can say, I want my year to add 99 to it first. Yeah? I think we probably shouldn't really work with the year itself. So let's say our number is equal to our year plus 99. Just to kind of keep it very clear as to what we're doing. Now I'd say my number is equal to my number divided by 100. Let's see what happens when we print this. It's not going to give us a correct answer directly and say yes, it's passing tests, but let's just print the number and see if it kind of outputs as expected. So let's run the tests. It's failing, which is expected. Let's have a look at the console output, 20, and the input was, so that's correct. It's that number is correct for that test. Let's go down to like test number 8 and look at our console output. This is saying it's the 1st century. Let's look at the input, 45, that's correct. So if we just return this number, we should have a working solution. Let's try it again. Yeah, because we're returning it now, so it's seeing it. So that is the correct sort of algorithm for one way of doing it without adding any extra libraries, without utilizing any like mathematical stuff or anything that's kind of part of, like we didn't have to import anything, put it that way. If we import mathematics or math, we could actually do a ceiling on it. So we could just do the year divided by 100 and do a ceiling of that, and then returning the result of that. So that would do the same sort of thing. At this point we've done what we call a floor divide by putting slash. That's a floor divide. It divides and ignores the trailing point something. So they're the two ways of doing it. You can either do that and floor divide, or you can ceiling divide using the math library. Okay, so we've done that one. I'm moving quite quick today, but that's because I'm doing 3 of them instead of doing 1. Now, let's take a look at this one. This one is check palindrome. Now, for those who don't know what a palindrome is, it's basically a string that is exactly the same even if we flip it around in reverse. So, for instance, mom is the same as the reverse of it, which is mom, because they're the same. Same with dad. So basically, according to that, shouldn't we be able to just check whether the reverse of the specific thing is the same as the straight going one? So what can we do with this? How can we actually do reversal? Now, we know we can reverse things like lists. So if I had a list or something, I could reverse it. Can we do the same with the string? Let's have a look. Let's just print what would seemingly be reverse of a string. Now, to reverse a string, there's quite a simple slicing technique that we can use in Python. So we could say input string and then index it as if it was indexed, but to slice we can do colon. So from beginning to end, yeah. But if you do from beginning to end, stepping by -1, That's one other way of doing it, but this may not work. Let's see what happens here. Let's print the input string and see if it is reversed. In fact, let's not even print the input string. Let's print something. Let's do input string, and let's take away that pass, otherwise it's never going to get to that line. Again, this is not going to pass any of the actual tests unless it accidentally passes something. It's not returning anything. Let's run the test and see what we printed. So let's look at the print. That's reversed input string, which is perfect. So that thing itself is reversing the word input string, which means it should reverse any string. So if I go and turn that into this specific input strings and run the tests again, still not going to pass anything. But if you take a look, it's reversed AABB to be AABB, which you couldn't really tell whether it was reversed. ABAC is the input string, CABA, so it's actually reversing them. So that would have said no, that's not true, which I think is correct. So what we can do now is we know how to reverse the input string. So we could just say return input string is equal to the input string reversed. If that returns true, so I've got an extra part of the old printer. If that returns true, then this will return true. So that means it's saying yes, it's a palindrome. So let's run that, and it passes the test, because what it does is it reverses it and checks that the same. The front ways input and the reversed input are the same, which equals it is definitely a palindrome. That's how simple it is. And that works for a single string, a single character, because the single character doesn't really move anywhere, and every other possibility. We could technically shortcut this a little bit, because we know that, well actually no, that's fine. This isn't good enough for the purpose. It's not a super long thing, it's quite easy to read. We could actually have done this manually, or if there was a language which had a reverse on there, we could do that. But for now, this does perfectly fine. And this is kind of bringing us to slicing in Python. So for the slicing, realistically, it takes the square brackets, the from, colon, to, and step. So the stepping of whether it's stepping forwards by 1, which is standard, or whether it's forward by 2, 3, 4, 5, or if you put a negative number, it's stepping backwards. So there's different ways of stepping. But from and to is the general slice way of doing things. Okay, now that being said, let's make sure it's working with all the hidden tests by clicking submit. And it is, that's correct. Okay, so that was quite a quick one. Hopefully it wasn't too strenuous on you. That was just the journey begins in the intro of the CodeSignal Arcade. So that was add, century from year, and check palindrome. In the next one, we'll probably have a look at the edge of ocean and see how many of those we can get done. Adjacent element product's an interesting one. That we could actually probably spend an entire video looking at. So these may be like one a day sort of things. So we'll kind of work our way through those as we go. It's been awesome making this video. Hopefully you enjoyed it, and I hope you've learned something. Thanks a lot for watching. I'll see you in the next one.